Hello! Okay, let's not waste any time. Let's jump right into this practice paper for the new Cambridge IGCSE specification 2025. Note all the formulas of graph they're going to give you this time around. And let's start with question 1. Find the value of m is minus 3, x is minus 2, c is minus. So we just need to substitute those values. Change the m for a minus 3. Using brackets is always a good idea. You can never go wrong with brackets. You can go wrong without brackets. Okay, of course, this is a calculated paper, so you might want to save your brain power on this. Minus 3 times minus 2 is 6. 6 minus 8 being minus 2. Okay. But you know, just don't take any chances. Don't take any chances. Type it into that calculator. Like it is. Don't be scared. Bam, to make sure you got the right answer. Okay. Mark scheme. Let's have a look there. Minus 2, just like they said. No problems. Question 2 is very early for a Venn diagram question in a paper. Let's go. Shade the region A intersect with B. Remember, there are things, different things there. There's A intersect with B, and there's A union with B. Now, union, of course, would mean everything. Everything in A, everything in B. Just to show you. So, union would be A. That would be union. Everything in A, everything in B. Okay. In A and in B, or in both. Where intersection means it has to be in both. Has to be in A and has to be in B. So the correct answer for this one would be just the middle there. Both in A and both in B. Shaded nicely. So don't have any reasons not to give you your marks. Okay, there it is. One mark only. Question 3. To my badly lit desktop camera here. So, in triangle ABC, BC 7.6. Be careful, right? There's AB, BC will go from this side upwards. AC 6.2. So we go like this. Use a ruler and compasses only. Construct the triangle. Leave your construction arcs. Okay. And they've already drawn the bottom part for us. So, I'm going to start by drawing the first one. BC with 7.6. So we need to make sure we open our compass exactly 7.6 centimeters. Okay. Make sure you got a nice stiff compass, not too loose. It doesn't change. Okay. And make sure you open it up exactly 7.6, which is easier said than done. Okay, there we go. You see? From 0 to 7.6, which is over there. And they put the sharp end at B because it's BC. Right on the edge there. And make a nice big arc like that. Next one, 6.2. So now we're going to change this to 6.2. There we go. Is that it? Correct it within a millimeter. Then remember, this is AC. Put the sharp end at A. And now we don't need a big arc. We just need to cross the previous arc. And there we go. These are our construction arcs. The ones they say do not remove. Okay. What's all that's left to do is connect B to where the two arcs cross. Make sure you're exactly on, right? How many students does all the hard work and then the last step is just not accurate enough. Okay, and then the same here from there to there. I got a wonky there. Okay, so of course this will be point C. This distance here will be 7.6 centimeters. And this distance here will be 6.2 centimeters. Do not rub out these arcs. And you'll get your 2 marks. Question 4, write 2 to the power of minus 4 as a decimal. Okay, you can just put this in your calculator, but let's see what it looks like without a calculator. Of course, that minus, the rules of indices, means if you have a number with a negative index, we can write it as a denominator, the positive. So that means 2 to the power of minus 4 will be 1 over 2 to the power of 4. And then, of course, 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So that's 1 over 16. Now, there's a long way to figure this out, and there's a quick way. Okay. You can do 1 divided by 16 and let your calculator tell you. But you could have just done it from the start. 2 to the power of negative 4 and not waste any time. Remember to know how your calculator changes between fractions and decimals. Practice that a little bit. Each calculator is different. Okay. And make sure you know how to do that. So this one is 0.0625. As the marks key shows there. Simplify. Remember, when we are multiplying fractions, let's give you an example. We just multiply the top with the top, the bottom with the bottom. 2 times 6 is 12. 3 times 7 is 21. Of course, there's a better way of multiplying fractions, and that is to simplify before you multiply. For example, we can divide this 3 by 3, and that's 6 by 3. It's like simplifying fractions, but before we multiply. So 3 divided by 3 is 1, and 6 divided by 3 is 2. So now we can go 2 times 2 is 4, and 1 times 7 is 7. That's a good way to do it. So let's do the same here, okay? We can just do P times 4PQ and 2Q times T, but it's always better to simplify before. This Q divided by that Q will cancel each other. So we're left with P times 4P, which is 4P squared, and 2 times 2 is 2T. Of course, there's something I missed, okay? We can make it even easier than that. We can divide this 2 by 2, which makes it 1 as well. And this 4 divided by 2 is 2. So now we got P times 2P. That's 2P squared over T. I think that's the most simple answer. Okay. I mean, if you don't do the simplification beforehand, you can just multiply them together. But then you have to simplify at the end. So P times 4PQ will be 4P squared Q, and 2Q times 2 is 2QT. Just then check, yeah? Then we can cancel the Q and the Q, and the 4 divided by 2 is 2. So you're left with 2P squared. 2P squared over T. Same answer. So anyway, simplify before you multiply, simplify after you multiply, whatever works for you. Just make sure you simplify all the way. Okay, so you get one answer for a correct unsimplified answer. So that might have been, if you forgot, 4 over 2, or not the Q's. Okay, full marks, fully simplified. Question 6, very important. This is not to scale, so you can't use your protractor to measure it. So let's see what it says. The bearing of B from A. Remember, you're traveling from A, so that's where we're at. We're at A. Bearing, we always measure them clockwise from north, which is 0 degrees. So that means this angle is 105. It does look like 105 angle, even though it's not to scale. Okay. That's what 105 should look like, more or less. Maybe it's 106, maybe it's 110, who knows. Okay, find the bearing of A from B. That means we're at B. Now remember the rules of bearings. You have to start from north, which is 0 degrees. That's the first rule. You have to go clockwise. And you have to write figures, which is not really relevant here. Okay, so this is now what we want to know. Of course, we're from B, we're at B, going clockwise. Right, so what would be that? How can we work that out? Let's first of all, get this angle here. All right, these are two angles between two parallel lines, because the north lines is always parallel. What we call them? Co-interior. Together, they're 180. That means we do 180 minus 105, which goes to 75. So this angle over here would be 75. Okay, but that's not the angle we want. We want the one on the other side. Now this is angles around the point. All the way around is 360. So 360 minus 75. What is that? 285. I think that's it. 285. What, you're still confused with the 75? You can look at it this way as well. If we extend this line here, we got a nice F there lying on its back, which of course is a corresponding angle. So this is 105, and together that's angles on a straight line. Again, that's 75. That's another way. Okay, either way, remember the rules of bearings. From 0 clockwise, three figures, which is not really important. Let's see what they got. 285. Yep, they got 180 plus 105. Yeah, write your answers in the graph as well. So they'll look at, oh, there's a 75 to give you a mark. Okay. Yes. And then they give a mark there. Or they look for the working out here and they give a mark there. Write as much, but also write things in the sketches, in the drawings. You can pick up marks there easily. Solve the equation. We need to get rid of that 3. Alright, this is division here. So how do we get rid of 3? We multiply by 3. Multiply both sides by 3. Multiply everything by 3. Or multiply the 3 on the other side. Hey, either way you've learned how to do this. You're going to end up with 1 minus x equals 15. Right, there's one or two things that we can do. We can move the 1 to the right hand side or the minus x. Most people, I think, is more inclined to move the 1 or subtract 1 from both sides. Okay. Do not lose the negative in front of the x. The negative, the sign, goes with the number it's in front of. So that 1 and the negative, they don't go together. Then y minus belongs to the x. Okay. So that means minus x equals 14. But that's not what we want. We want the x without the minus. What do we do with the minus? Well, there's lots of things you can describe. You can say that I can flip the x to the other side so it becomes positive and move the 14 there so it becomes negative. You can say, well, it's a minus 1, so I'm going to divide the 14 by a negative 1, so that gives me minus 14. Or the most simple answer is just, if you ever end up with a negative you don't want, just change the sign of everything. Okay? Which means I've got minus x, means x equals minus 14. Change the minus there, change the minus there. Okay, just deal with the minus. It needs to be there to get full marks. Okay, look, you can already get 1 mark for just multiplying the 5. Okay, and there's other methods to do that. I don't like to go through all the methods. My videos is already too long. But yeah, you get 1 mark for just doing that. And then, of course, correct answer with the minus in the right place, you get full marks. Question 8. It's time to draw a train. Okay. Now this, ladies and gentlemen, is my platform. It's 225 meters long. This is my train. Okay, train with wheels. Okay. That train is 105 meters long. So here comes the train. It's moving, it's moving, it's moving quite fast. It's not going to stop at the station. Stand back from the platform, yeah? Okay, so it goes and then goes and then its front nose. Well, let's say at this point here, the clock starts ticking. When that front nose is level with the platform, we go tick, 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 tick. Clock starts ticking until the train's front nose, yeah, put less wheels on my train, it's faster to draw, okay, is level with the edge of the platform. Okay. Has it passed the train station completely? No, because there's still, most of the train is still level with the platform. Okay. So it means it needs to keep moving. Okay, hasn't gone past it yet, but it has now traveled 225 meters, definitely. Okay. The clock continues to tick, 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 right? Until the end of the train. And I just need to touch there. Okay, till the end of the train. This is a train kissing the bum of another train. And the moment the back of the train passes, now it's finished going past the platform. Okay, how far did it travel from there to there? Well, the length of the train, which is 105 meters. So in total, the train will travel 225 plus 105 meters, which of course will be 330 meters. Good. Now we got the distance it traveled. The moment, of course, when its backside leaves the platform, clock stops, 11 seconds. Okay. So we now need to do our speed, distance, time triangle. Okay, and that is given to us every single time they say speed. Kilometers per hour. What's kilometers? It is distance. Per hours is time. And that is speed. Okay, so the kilometers is the distance and the hours is the time. Speed, distance, time is in the formula. Kilometers divided by hours, distance divided by time. So they want the speed, so we say the speed is distance 330 meters time 11 seconds. But that will give us the answer in meters per second. We want it in kilometers per hour, so we need to change things. How we change meters to kilometers? Kilo means 1,000. Divided by 1,000, which is 0.33. Check it with your calculator. Okay. And then, let's leave it at that. Divided by 11 seconds. I like it. So, you can see what that is. That will be 0.3 kilometers per second, isn't it? 0.33 divided by 11. 0.03. Remember, this is now kilometers. And that means we're traveling at 0.03 kilometers per second. In 1 second. How much is an hour? Well, we need to first times it by 60. So it travels 1.8 kilometers in a minute. Times it by 60 again. 108 kilometers in an hour. So what did we do? We did 0.03 times 60 minutes, hours, 108. That sounds like a possible speed for a train. Not the fastest train, not the slowest. Maybe it slows down when it gets to the platform. Trains are faster than that these days. 108, correct answer. Okay. They got slightly a different formula there than I did, but it's the same effect. So you get 1 mark for this. One mark for adding the two distances together. 1 mark for your calculation, which I've divided 1,000 there and multiplied the 60 and 60. So you get 1 mark for your working out and then 1 mark for the final correct answer. Question 9. Divide $24 in the ratio 7 to 5. So you got 2 buddies. You give the one 7. Well, you're giving stuff away in the ratio 7 to 5. So let's say you do give your one buddy $7 and your other buddy $5. That's a total of $12. But you got actually 24 to give away. So you need to do it twice, of course. Yeah. 24 divided by 12 is 2. You need to do this twice. You need to do the ratio twice. So you're going to give the first buddy $7 twice. And the second buddy $5 twice. Which means the first one now gets 14 and the second one 10. And that's how you hand out $24 and the ratio 7 to 5. You give the ratio until all the money is gone. Okay, this is the formula there. 24 divided by 12 to get 2. Okay, so this is actually the rule. This is a really easy question to explain, but they can have very difficult numbers. So the rules is always add the ratio together and then divide the original amount by the answer and you multiply the ratio what you got. So this is 1 mark and 1 mark for both, correct. Okay. Question 10. Right, $24.60 as a fraction of $2,870. Okay, whenever they say write something as a fraction as another thing, that's what we do when you have an exam. You got an exam out of 50, you got 40, or no, you're smart, you got 48, you got 48 out of 50, that's a fraction. We got $24.60 out of 2,870. Now you can go and simplify this and do crazy stuff, but this is a calculated paper, so you're not going to waste your time. You're just going to go, you can start as a fraction if you want, 24.6 over 2870, and your calculator will give you the answer, 3 over 350. If your calculator didn't give you the answer, make sure you have a calculator that you know how to use. You can swap between decimals and fractions. I'll learn how to do that. Okay, 3 over 350, correct answer only. Okay, so that's 2 marks. You're not going to waste your time trying to simplify this. But they said if you did simplify it, but not fully, you can get another one. I guess like $12.30 over 1,435. I just halved it now. You get 1 mark for that, for simplifying. But don't, use your calculator. Question 11. In a sale, the original prices are reduced by 15%. Now this is very important. If I reduce something by 50%, I take the original price, which is 100%, subtract 15%, and that means the final price would be 85%. This never changes. Doesn't matter what you do, whatever price you have, okay, and then it's 85% of the original price, or as a multiplier or as a decimal, that is 0.85. Okay, that we'll call the multiplier because that's what you multiply it by. So like in A then, if you've got the original price, you need to multiply it by the multiplier and you get the sale price. That's sale price. Easy as that. Something costs $12. We're now going to reduce it. We're going to only charge 85% because we're doing a 50%. That gives you the answer. So you do 12 times 0.85. It will now be $10.20. Okay, $10.20. Don't have to put that 0 to get your marks. And there, see, this is what I explained. That will give you a decimal of 0.85 times 12 or better. Okay, you get 1 mark for $1.80. That's how much. So if you worked out 15% of the original price, which you can do, that's $1.80, and then subtract it, you get $10.20. So that's another way of, a longer way of doing it. You get 1 mark for that $1.80, or how much it went down, and then full marks if you subtracted it. But best is just to get the multiplier and multiply it. Now in question B, we're moving backwards. Remember what I said? It's the original price times the multiplier give you the sale price. Now they give us the sale price. We said that is $38.25. The multiplier has not changed. It is what it is, which is 0.85. We now need to know the original. So we're doing this equation backwards. So that means we need to move that there. So the original price would be 38.25 divided by 0.85. Okay. Now remember, the original price needs to be bigger than the sale price because this is a sale. They're reducing the price. How do you get something bigger when you're dividing it? And the answer is yes. If you divide something by a decimal with something smaller than 1, it does get bigger. So 38.25 divided by 0.85 gives us $45. And that makes sense, because if I'm going to take $45 times it by 0.85, I'm going forward now and I get 38.25, which was the original price. 45, there it is. And this is a complicated way to say divide, see, or equivalent. So it doesn't have to look exactly like that in your exam. You just need to show it. So you can just, if you do this step, divide by 0.85, final mark. Don't stress it. Okay. So you just want to ask yourself, the multiplier never changes. The question is you're moving forward in time, you multiply. If you're moving backwards in time, you divide. Question 12. Now they've given us this nice formula sheet, but the formula for simple interest is not there. Okay. So you need to memorize this. Simple interest is I equals P R T, principal rate time over 100. Okay. I interest. P is the original amount you start off with. R, the rate, that's in the percentage. You just write it as it is because the division of 100 is there already in the formula. So don't change that in any way. And T, of course, is the time. So if you want to know the interest, you'll do 500. The rate is 1.7. Time is 10 years. And you just put it in. Grab your calc. $85. Does that make sense? Yes, because they're not asking you how much money you have, or Dean has in the bank. It's Dean, right? They're asking how much extra. That's the interest. And the simple interest formula gives you only that. It gives you the interest. Of course, you have $585 in the bank, but they say the total money, only the interest earned. Okay, so we're right. 85, and that's the formula, straightforward or equivalent. So yeah, you get a mark for using the formula, a mark for the correct answer. Now we get to Ollie. I think Ollie is going to a better bank. Or is he? Compound interest. Again, you need to learn this formula off by heart. Compound interest starts with A, which is the total amount. It's different from the the simple interest one. Simple interest one only gives you the interest. For compound interest, formula gives you the total amount of money you have at the end. And then we got the P again, the 1 plus R over 100 and T. Okay, so P, the money you start off with, R, the rate, again, don't change it because it's division by 100 in the formula, and the time, which is per day. You see something is in bold, is there bold for a reason. 360 days every day they're going to calculate this. So the amount of money you'll have in the bank is 201 plus the rate 0.0035 over 100, and the time is 365. Put in your calculator. And there we go, 202.57. Money, 2 decimal places is good, I think. Does this make sense? The value of his investment. So there's not all the money. I mean, there's not just the interest. It's all the money. So he only gets $2.57 over a year. Okay, maybe it's not that great a bank. Who knows? Let's see what the mark scheme says. Okay. Right. So, first of all, a mark for using the formula correctly. 1 for me, right? You don't get any marks for writing down the formula. You get it for putting stuff in the formula correctly. Then, 203, 202.5 to 202.6. So that means if I rounded it to 3 significant figures, correct. If I rounded it to 1 decimal place, correct. Or the way I wrote it, 2 decimal places, correct. Or even if you have more decimal places, they say anything between 202.5 to 206 is correct. So the rounding, as long as you do it right, okay, it doesn't matter how you round it to how many decimal places. Just don't do 200, for example. Question 13. Know your index laws. A power to a power. Remember, that could be a little 1 there. A power to a power you multiply. So it's 5, 1 times 3. And x to the power of 4 times 3. A power to a power you multiply. So 5 cubed. X to the power of 12. And of course, you know what 5 cubed is, but if you don't know, just put in your calculator. 5 times 5 is 25. 25 times 5 is 125. So you need to simplify means also calculate what you can. Yeah. See, work that out. So you get 1 mark here for the 125 and 1 mark for the 12. Question B. Again, a power to a power. So, same as before, 1 there. 1 times 3 eighths is 256 to the power of 3 eighths. x, and 256 times 3 to the power of 8. Now, let's not waste our time with this, okay? That actually means 256 to the power of 3, 8 means root 8, 256 cubed. Okay, but you don't waste your time. You just put it in 256 to the power of bracket fraction 3, not 8, gives you the answer 8. I mean, if you want to break it down and do shift root 8, wait, I'm not saying I need this bracket, 256 cubed. That's what I said, isn't it? Same answer, see? For the x part, we just do 256 times 3/8. Divide by 8 times 3. 96 is x to the power of 96. Check the mark scheme. Yes, that's correct. And again, same as the other one. You get a mark for the 8 and a mark for the 96. Question 14 is 4 marks. You know there's something going on here, some action. The diagram shows a sector of a circle, radius 8 centimeters. Moment you sector of a circle or an arc, yeah, or a slice of pizza, basically. If you see a slice of pizza, remember these two formulas, which they don't give you in the formula sheet. Let's just double check. No, it's not there. So this is one you have to memorize. 2 you have to memorize. Okay. Area of a sector is the angle, which we don't have, over 360. This is just a fraction. This is what fraction of the pizza do I have? Is that angle divided by 360 times, and this area it's got to do with a circle. It's pi r squared, area of a circle. Then you also get arc length. What's an arc? This is an arc. A piece of the circumference of the circle. Again, what fraction of the pizza do we have? Okay, so the angle over there times, and now because we're talking about circumference, you can do pi d, but better is 2 pi r because they usually give you the radius. Okay, remember this is part of a whole big circle. Yeah. We can say this is a whole big circle. So that would be the radius. Very wonky circle. But anyway. So we got this information. Let's see what we can do with it. Diagram shows a sector of a circle of radius 8, the length of the arc, find the area. So, that's it. We're going to use this formula, but we don't have that angle. We got the radius. Yes, we got the radius. We know what pi is. It's a button on our calculator. But we need that angle. So let's go to the other formula, arc length. Well, we got the arc length. There it is. We got that one. Okay, we got the radius. So maybe we can use this to find the angle, that one. Okay, let's do that. So we're going to use that second formula. The arc length is 6.4 equal that angle times 2 pi radius. We got that 8. Alright, so what shall we do? Let's start easy. So we know it's 6.4. 2 times 8 is 16. Let's divide that 16 on the other side. 6.4 divided by 16 pi. And to get rid of 360, we're going to multiply it. So 6.4 over 16 pi times 360. That little egg with a arm sticking out that I'm drawing, that's the theta sign. You'll have to use that Greek symbol, I think, for angles at sectors. I don't know why. They just love to use that one. Anyway, that's it. It just means the angle for that. All right. So, calculating. 6.4 over 16 pi times 360. I like the all at once. 45.8366. Don't round this yet. Okay. Now this, every examiner's report of every exam I've read, examiner says students should be reminded not to prematurely round their answers. This is an example of that, right? Do not round it to 45.8 or make it shorter. I've written 6 significant figures, by many, at least 4, but do we say 5 significant figures? Okay. We'll bring you home safely to make sure you get the correct final answer. Okay. Now, we got the angle. We got the angle. So we got this guy. We can now get the area of the sector by using this formula. Sweet. So, what was the angle? 45.8366, etc. divided by 360 times pi. Radius is still 8. That's it. Let's do that. Okay. Now, see, I still got that answer on my calculator, the full one. The irrational number with the infinite amount of decimals. So, if I now just do that, divided by 360, is that times pi 8 squared. And look how nice, this is already a rounded answer, 25.6. They're very nice, they put the units for us there, so don't stress about that. 25.6 centimeters square. Let's see if I got it right. Yes, 25.6, spot on. They do have some leniency if you did use a rounded answer, but be careful. If you don't have 25.9 something, if you're better off 25.58 or 25.61, then you're going to lose a rounding mark there. Okay. Now, this looks complicated. You see, all this is or equivalent, so your working out doesn't have to look exactly like that. I mean, what I've done here is pretty sweet. Show it in the formula. They don't give a mark for having 48, 45. They don't. Yeah, basically, we'll give the mark scheme makes it very complicated. But if you use these formulas, they marks, and then for the working out. Okay, my professional opinion anyway, where the mark should go. Moving on to question 15, and it looks like there's a lot going on. We just need to go through every little bit of detail very slowly. Okay, they tell us this quadrilateral here, ABCD, is a field. Imagine sheep grazing stuff. The bearing of B from A is 140. Let's get out of this as much as possible. Okay, what do we know about bearings? Bearings always starts from north, which is 0, 0, 0. We go clockwise from A to B. Okay, that means at B, we can draw another 0, 0 north line. And then if you remember, angles, co-interior angles, because we've got two parallel lines. If this is 140, then this will be 40, because co-interior angles adds up to 180. So already we have another angle here, which is 40. Okay, see things is coming together there. Next piece of information. We got that. C is due east of B. So due east, this means this is due, right? So then we know this is a 90-degree angle, because due east is 90 degrees. Here we got another angle, then we got the 90 plus 40, 130, if we ever need it. D is due north of C, so again we know this is 90 degrees. Okay. And then they tell us the distance AB is 400, BC is 350, CD is 450. Okay. Let's see the question. Show that the bearing of D from B, let's change the color a little bit. Of D from B means we're going from B to D. Bam. What is the bearing? Well, they're giving us the answer there, which has been rounded to one decimal place. They're giving us the answer. Okay, remember, bearing means we need to go from north, which is 0, 0, 0. We have to go clockwise, and we're at B. So what they want to know is this angle here. Okay. What do we know about the angles? Well, it forms part of this 90-degree angle that we know. Okay. And the other part of the angle down here forms part of this triangle. So, what do we know about this triangle? Well, it's a right angle triangle, which means we'll be able to use either Pythagoras or Socatua. Now, Pythagoras only deals with the sides, not with the angles. Okay, we got two sides, brilliant, but we don't want to know the third side. For now, we don't want to know the third side. Socatua deals with angles and sides, and if we can find the angle here, then we can just subtract it from 90 and we'll have the one we need. Easy as that. So let's label the sides. In this triangle, this is the hypotenuse, the longest side opposite the 90-degree angle. We're not going to use it because we don't want to know it and we don't have it. But what we do have is the opposite and the adjacent to this angle here. The O and the A. Socatua. That gives us the last bit of tua. So it tells us we're going to use the tan rule. So let's write it down. Let's write tan and then the angle. We need to label this angle. I'm going to call it angle D, B, C, or even better, CBD in alphabetical order. Okay, CBD. You can label it X or Y or whatever. We got the O first and the TOA ratio, so we need to put the opposite first, which will be 450. And then it's the adjacent, the 350. So to get the angle CBD, move the tan there. We do the inverse of tan minus 1, over 450, 350. Let's put that in our calculator. 52.125. This is not our final answer, so we're not going to round it. Remember what we wanted to do. We wanted to find this angle here. And that forms part of this 90-degree angle. So what we need to do is we need to do 90 degrees minus 52.125. So let's do that. Let's do 90 minus previous answer, and we get 37.874. Very important now, we need to show that it rounds collected to one decimal place. So we need to show more digits, and then we round it to 37.9. Brilliant, that's exactly what we wanted. Let's look at the mark scheme, because these showdown questions are very important, that you show everything you can. Okay, so for having done 350 over 450 or equivalent, that's one. I want this in red because we're marking. Okay, that's 1 mark. Oh, this is only 2 marks. And then look, you need to have not the rounded answer, something more than the rounded. So you need to have this bit to get that mark. So remember, write the unrounded answer, very important. Question B here, calculate the distance from D to A. So let's have a look. Let's switch some colors here. To make it from D to A is this distance here. Okay, which forms part of this right angle triangle, this one here. So let's make that one green. Okay. So there's this green triangle. So what do we have in this triangle? Well, not a lot, really. I don't have really any of the angles. Okay. So let's go to another triangle where we got more information. And we'll do this one in orange. This triangle here. Okay, because in this triangle, which we know is a right angle triangle, we have the hypotenuse. We have this angle, which I said is 40, but you can also get this one here, of course. If this is 90, and you do 140 minus 90, you get 50, which will be this angle here. Or you do 180 minus 90 and 140. Okay. So we got a lot of information in this one. So let's start there, right? We're going to be looking at this triangle first. Okay, so we can work out more things in this triangle, which will help us. Okay, for example, let me call this side x. If we have x, well, x, then we can get the height of this triangle here by subtracting from 450. Okay, so I'm going to use this angle 50. For 50, we got the hypotenuse 400, and we got the we want to know the opposite rather, which I've called x. Okay, so using the O and the H, of course, sukatua, which there's the O, there's the H, so we're going to use the sin ratio. So let's write that down. Let's start down here. Sin, the angle, the opposite is the x, and then we got the hypotenuse, which is 400. So if we want to know what x is, we just simply need to multiply the 400 with the sin 50. Let's do that. 400 times sin 50. Don't have to put the times in. We got x, 306.417. Do not round this. We only round at the end. Okay, so remember now, if we subtract that, I'm going to call this point here E. If you subtract that distance, 306, from x, then we can get this distance, DE. Yeah, let's call it DE. So DE is 450 minus 306.417. So we just do 450 minus our previous answer. We got it, 143.587. 143.58. You know what? 4 significant figures would probably be alright for not rounding it. I do 5, sometimes 6 if I like it more. I do 6. Okay, so good. We have this distance, 143 point. What was it? Something. 58. Right, now we got this 350 here, so we know that this is also 350. We can find this distance, which I'm going to call y. We can add it together and we will have the total base of this triangle, which is good news because remember we're going for DA. So let's do that. What is the y? Well, the y is the adjacent. And we got the hypotenuse. So if I'm going to use the adjacent and the hypotenuse, it is the cos ratio. So let's do that then. Cos 50 is the adjacent, which is y, over the hypotenuse, which is 400. Multiply the 400 over there. That means y is 400 times cos 50. So we got 400 cos 50. 257.115. Etc. Remember that is not the total distance, this is only this part here, so if we add it to the 350 we'll have the total distance AE. So AE is 350 plus that. So we can just add 350 to that. 607.115. Right, now we can swap to the green triangle. So we now have these two distances. We've got AE and DE. We're working with the sides of a triangle, so we can use Pythagoras. The distance we want there, DA squared, would then be DE squared plus AE squared. That is the old Pythagoras rule. Okay, if you want to make it even easier, let's just move the square to the other side. So it's the square root of DE squared plus AE squared. But be careful writing stuff here where I'm writing it. We should be writing it down there where they're going to mark it. So DA equals the square root, what was it? DE squared plus AE squared. Which was the two sides we just worked out. DE was 100. It was 143.58 squared. And the other one, AE, 607.155. Put that in our calculator. Don't forget to square it. And we get 623.86. Excellent. Remember, if you're going to round it to 3 significant figures. 624. Let's look at the mark scheme. It's quite a big question, this one. 624, or the unrounded answer is also good. But if you do have the unrounded answer, make sure it is within those parameters, because if you round it earlier on, it might not be accurate enough. Okay, it's pretty straightforward. It seems you get 2 marks. 1 mark here. Let's go to red. 1 mark here for that. A mark for that. A mark for Pythagoras. and a mark for the answer. That's how I understand the mark scheme. Anyway, question C. Jono is running around the field, chasing sheep maybe, I don't know why. He runs at a speed of 3 meters per second. So, meters per second, which means meters per second. That is speed. That is the formula. Meters, of course, is distance. And seconds is time. So if you get the formula, they give it to you right there. Meters per second, which means distance divided by time. Okay. So, we want the total time taken, so we need to take the distance divided by the speed. Here we got the speed, so we first need to get the distance. The distance from A to B, from B to C, C to D, and D to A. So it's 400 plus 350 plus 450. Let's add it all up. Okay, A to B is 400. Then B to C is 350. Then C to D is 450. And then D to A is what we just got before, 624. Okay. Just to make sure we're very nice and accurate, let's use a bit of the unrounded answer. 623.86. 620.9. I'm going to use 623.9. Let's say you want to do this question and you didn't get the answer to the previous one, right? Make it up. Make up a number. Yeah, make it 1,000. Make it 500. Well, it doesn't matter what you make it, because you can still get your marks here, or 3 marks at least, by doing the round calculations, even with the wrong numbers, right? So, we need to add that up. 1,823.9. meters. Okay, so distance divided by speed will give us the time. So we go 1,823.9 meters divided by 3 meters per second. I write the units here because it's important, right? So this meters will cancel with the meters, and that will tell us our answer is in seconds. Okay, meters divided by meters per second will give us seconds, because with what we want the time. Okay, now so it's this number just divided by 3, 607.96. Recurring, by the way. Okay, they want it in minutes and seconds, of course. We need to divide that by 60, because that's how many seconds is in a minute. So let's divide it by 60. So it's 10 minutes. But is that 0.1, is that 13 seconds? No. That is 0.1327 recurring of a minute. Does that make sense? Let me write this down. 10.1327 recurring minutes. Okay. But this here is a decimal value. This is out of tenths, hundredths, thousandths. It's not out of 60. Okay. To get that, the actual seconds. This is like saying this is roughly 13% of a minute. Yeah, it's a fraction of a minute. It's not the actual. This is different base numbers. Time is so weird. We count up to 60 and then we start counting again. Whereas what I got there is a decimal value which goes up to hundreds or thousands, and then you start counting. This is different. It's different, okay? So we need to say, what fraction of this of a minute is that? So let's first I'm going to take away the 10. Okay, so this is a fraction of a minute, and a minute is 60 seconds. So we need to times that by 60. What is 13% of 60 roughly? 7.98 seconds, right? We round that, 3 significant figures, we're going to get 8 seconds. So it's 10 minutes, 8 seconds. You see that? Yes, 10 minutes, 8 seconds. Does that make sense? Okay, you see that 10.13, etc. that only gives you 3 marks. You need to change that decimal value to seconds to get full mark. Oh, okay. So let's see where the other marks is awarded. You get 1 mark for adding everything up, 1 mark for dividing it by 3. Okay, and look here what I said, yeah? Their DA. So if you got the previous question wrong, then you can write anything there and then use that, and I'll give you the answer. Question 16. The speed of each of 200 cars, remember there's a 200 there, don't forget about that 200, passing a building is measured. So they show us that there were 16 cars that drove very slow. Most cars were driving between 40 and 45 kilometers per hour, and then there were 4 cars that were really speeding along between 60, more than 60 and up to 80 kilometers per hour. They tell us to calculate an estimate. Why an estimate? Because we don't know the actual speed of the cars. We know within a range, but we don't know exactly how fast they were driving. Like the first 16 cars, they drove somewhere to barely moving up to 20 kilometers per hour. So what do? We take the midpoint, which in this case will be 10. Halfway between 0 and 20, 10. So we assume that on average, those cars have been driving about 10 kilometers per hour. The midpoint of the next one, between 20 and 40, is about 30 kilometers per hour. The next one, between 40 and 45, well, that's 37.5. But if you're ever unsure of how to find this midpoint, you just add the 2 numbers together and divide it by 2. Okay, that will give you the exact midpoint. So is there any uncertainty? Add it together, divided by 2, and you'll see. See, I was wrong. I said 37.5 is 42.5. See, I wasn't paying attention. Any uncertainty, add it together. So the next one, I'm pretty sure it's only 5, and halfway between 5 is 2.5. 2.5 plus 45 is 47.5. But if you're not sure, just add it together and divide it by 2. Next one is 55, and the last one is 70. If really, it's better just to make double sure of all of these, because it's so easy to make a mistake. Okay, so the next one, remember, calculating the mean, is you need to add up all the speeds of all the cars and divide it by how many there is. So this is quite a calculation. Take your time, don't make mistakes. Those first 16 cars, they were driving around 10 kilometers per hour. So that means altogether they've been driving 160 kilometers per hour. If you add their speeds one after the other. Yeah, you know what I mean. Okay, then we need to add the next 34 cars, which was driving about 30 kilometers per hour on average. Then we need to add the next 62 cars who was driving about 42.5 kilometers per hour. Next is 58 cars at 47.5. You get the idea. Okay, so there we'll have you all the speeds of all the cars added together, or an estimate of what all the, okay? And then we need to divide all of that by how many cars there is. You can add up this frequency column, right? But remember, they actually told us at the beginning how many there is. So save your time. Divided by 200. Okay, now be very careful when you put this in, not to press any wrong buttons. It's easy to press. It's even better actually to do it separately. But it's easy to press a a add when you should press a times, or a times you should press an add. So take your time, make sure you do it right the first time. So I get all their speeds at 8,280, which we then divide by 200. $41.4. Does that make sense? Where is 41.4? Well, it will be in this group here, which is around about the middle. So it's definitely an answer that makes sense. Okay, if you press a times by accident with a plus, you'll get an answer that's way too big. You think, oh, I must have made a mistake. Think if it makes sense, right? If you get 75 kilometers per hour, it can't be, because there are only 4 cars who drove in that area. You know what I mean? Or you get too little. Let's look at the mark scheme. That's correct, 41.4. Okay, and the marks here is awarded as follow. Okay, you get a mark for showing the midpoints correctly, most of them. You get a mark for multiplying and adding together. Then you get a mark for dividing by 200, and then a mark for the final answer. So if you do make a calculation mistake, but you've shown all your working out, you can get 3 out of 4, right? That's why it's important to show every step. Next question is cumulative frequency. Cumulative, of course, means to gather all along, to gather up. Okay, so let's just go, yeah? Let me use a different color. So, you see the 16 here? There were 16 cars that drove 20 kilometers per hour or less. Then they added to the 16 the next group, the 34. So, less than 40 kilometers per hour is 16 plus 34 is 50 cars. So for the next group, we need to add the 62. So we need to be 50 plus 62, which is 112. All right, 112 cars drove 45 kilometers per hour or less. Then we need to add the next one, which is 58, which will give us 120 plus 50 is 170. Then we need to add 26, and yes, 170 plus 26 is 196, so we know we got it right, and you add the 4, you get the total. All the cars were driving 80 kilometers per hour or less. Okay, that's the cumulative frequency. Very important now, if we're going to draw this graph, use a pencil, of course, make any mistakes, but you need to use the upper, here they've shown it to us, the upper edge of the boundaries. Okay, sometimes they don't, then you need to know, right? With calculating the mean and estimate, you need the middle, but calculating or showing the cumulative frequency, use the upper bound of the groups they are put in. Okay, so the first one here, 20 kilometers per hour or less, 16 cars. Look at the squares. They are going up on 4s, are they not? Let's zoom in. Do this right. Okay, let's count them. 4, 8, 12, 16, 20. So they go up on 4s, yes. So 16 is 20 is 4, 8, 12, 16. Right there. Be accurate. 40 kilometers per hour or less, 50 cars. So 40 and 50 would be the halfway between 60 and 40. Then we got 45 and 112. So 45 is here. 104, 108, 112 will be right there. 50, we go to 170. 60, we go to 196. It's just 4 below. The final one, 80, 200. And that gives you that cumulative frequency graph shape, which is always the same. And you draw this by freehand. Okay. but make sure you go through every point. It's a lot easier on a piece of paper than on a smooth screen. Okay. They don't tell us what it looks like, okay, but there you go, plotted right. And there's an easy 3 marks in it for you. Okay, see, it looks like it's curving down here. That's maybe not good. Okay, I think this can be done better here. Ah, damn it. Slightly better, as long as the plots are good. Next one. Find your darling to find an estimate of the upper quartile. What's a quartile? A quarter. It's a quartile. Upper quartile is the upper quarter. Okay, now this is not too hard to do. 200. First we take 200, we chop it in half. Okay, that would be the median, of course. So at 100, we'll have the median. And if we chop like a pizza, cut it in half, cut it in half again, we get a quarter. So half of 100 is 50. And this will be the lower quarter. The upper quarter is the top half, we cut in half. So again, at 150, that will be the upper quartile. Okay, so we chop the 200 cars. We take the bottom half, we take the bottom half of the bottom half, that's the lower quarter. And then we take the upper half, and we cut it in half and get the upper half of the upper half. That's there. You can get the idea. So take your ruler, which I don't have at the moment, and you go across very carefully until you meet your graph. And then you go down. And show this on the graph, because whoever marks it, they see this, they say, hey, this guy knows what he's doing. This guy or girl, and we're going to give them the mark straight away. So here on the bottom, it goes up into 42, 44, 46, 48. 48 kilometers per hour. So the upper quartile, the top 75%, drove 48 kilometers per hour or more. Let's see what the mark scheme says. My goodness, there's no leniency here at all. 48 or nothing. That's what the mark scheme says. So be accurate, yeah. They don't give for 47 and a half, they don't give 48 or 48. Moving on to question C here. And we're now picking cars at random. 2 cars are chosen at random. Find a probability that they both have a speed greater than 50 kilometers per hour. So let's first see what is the probability of having a speed greater than 50 kilometers per hour. Okay, that means it will be a car that falls into one of these 2 groups, because these 26 and this 4, speed is greater than 50, so that is 30 cars. And remember the total was 200. So it's 30 out of 200 cars. Okay, we've picked a car. There's 200 cars standing on the parking lot. We parked them all after they've driven past the building. Pick one at random. Probability of it being drove faster than 50 kilometers per hour is 30 out of 20. But we have picked this car now already. Now we need to pick another one. Okay, we've picked one. Second car we're going to pick, there's less cars to pick. There's one less, only 199 left. Okay, and we've already picked one that drove more than 50 kilometers per hour. That means there are only 29 cars left. So those are our 2 cars that we picked, and they both drove more than 50 kilometers per hour. Next thing we decide, what are we going to do? We're going to add this or multiply this, because we're not going to subtract or divide. Add or multiply. So that's where the probability rules come in. The AND rule and the OR rule. Remember this. If you roll a dice and you ask what's the probability of throwing a 2 or a 3, you're going to add those probabilities together. This happening or that happening. Okay, but if 2 things has to happen, the one after the other. Okay, not the one or the other, the one and the other, then we multiply. The OR rule is, what is the probability of throwing a 1, a 2, a 3, a 4, a 5, or a 6 on a dice? you add up the probabilities of 1 or 2 or 3 or 4 or 5 or 6, or. But the and, that's multiplier. Okay. Also, we've been adding here, we will run out of probability very quickly. So, let's do that. Okay, so 30 out of 200 times, you can use this as decimals if you want to, or percentages, but this is the best. 87 over 3980. Okay, I mean if you want to write it as a decimal, you can, it's just look at that. How, yeah, this is better. 87 over 3980. Let's look at the mark scheme. Yep, or equivalent, which means you can write it as a decimal or a percentage. Okay, you get 1 mark for showing the first part. So you need to show all of this. Again, they're a bit strict on this mark scheme. You have to have all of this and this. And then of course you can write 0.0219 at least, rounded to 3 significant figures, or 21.9% with or more digits, but not less. Not less than 21.9 or rounded wrongly. It's better just to write it as a fraction. Histogram. Okay, remember again, histogram has got a little formula. What is there in a histogram? The way I remember this is that the area of a bar in a histogram, okay, the area of the bar, this is not correct, this is not what the bar is going to look like, equals the frequency. So it's a rectangle. This is a rectangle. This is the class width. This is the frequency density. You multiply them together, you get the frequency. So the formula is frequency density, which I will write as FD, times the class width. That means how wide it is here. Okay, class width. This class width here is 40. There from 40 to 50 is 10. 50 to 80 is 30. That would be the class width. Okay? Multiply them together and it should give you the frequency, which is this one here, which I've dubbed the frequency. Okay, so let's do this correctly. So let's get started. So what do we want? We want to do now, we want to find, well, we got the class width. Let's use our pencil. Got the class width for the first one is 0 to 40. So this is how the bar is going to start here. All right. We need to get the frequency density to see how high the bar is going. We're going to take the frequency, in this case, which is 50, and divide it by the class width, which is 40. And that, of course, will give us 1.25. So this bar is going up to 1.25. That's very, 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 very low. But yeah, we got, look at it, 2 squares. That's 1, 2, 3, 4, then 5. So each 2 squares is half a value. So 1.25 really would be right there. Please use a ruler to do this. Okay, that's the first bar. Second one is 40 to 50, so this is going to be a little narrow bar. Here the frequency is 120 divided by the class width, which is 10, and that will give us 12. That makes sense. So remember, 2 squares is 1 value, so that's 10, 11, 12. 12 is here. So we need to go up. Okay. Nice. Last one, 30 and 30. Of course, 30 divided by 30 equals 1. Now we know 1 is down here and it goes from 50 to 80. So 2 squares. See that? If there is a little bit of daylight, they call it, there or there, they've got reason not to give you marks. That's why you use a ruler. Let's look at the mark scheme. Yep, look at that one. 1.25. Okay, you get 1 mark for each correct column. Now if you didn't use a ruler and it's not perfect, man, you're gonna lose a mark. There should be no gaps. Okay, look, here should be a gap because that is in the middle of 2 squares. But if you go a bit wonky and you slip and you go like that, wrong, because you're going up. Okay, use a ruler. If you got this wrong, you can get marks for the frequency density, 1.2, 12, and 1. Just put a little bit of effort in, do it right. Yeah. Question 17. Triangles. Trigonometry. If it's a right angle triangle, you use Pythagoras or Sukatua. But these are not. So you know. You see them. It's calculations. You know you're either going to use the sin rule. And to know when to use the sin rule is very easy. To use the sin rule, you need to have an angle and the opposite side. If you've got an angle on the opposite side, then you can work out, use the sin rule. If you've got more information, but you have all the information. You need to have another angle or another side, but then you can work it out. Okay. Or, of course, the cosine rule. Cosine rule is 2 things. If you've got 2 sides and the angle between them, then you can work out a third side. Or if you've got 3 sides, you can work out an angle. That's what we use the cosine rule for. So let's see. Calculate QR. QR is this over here. It forms part of this triangle here. I'm slipping very much today. Okay. And what do we have? We've got an angle and the 2 sides, which is like this one. So you're going to use the cosine rule. Okay, cosine rule, of course, is on the formula sheet. There it is. Okay. So first thing we do, we write it down. Okay. So which is a squared equals b squared plus c squared minus 2bc cos a. Now what is a and a? Okay. The lowercase a would be the side you want to know, which make the angle opposite that the uppercase a. So they've called it something else. We can say that is our a. The b and the c is the other 2 sides in any order, doesn't matter. Okay. And then of course we can move that square to the other side, so it becomes square root. So first of all, the lowercase a is QR. That's what we want to know. We're then going to square root everything to get rid of this square. Okay, and then b and c, the 2 sides, lowercase b and c, the 2 sides in any order. 120 squared plus 150 squared minus 120, 150, let's extend this line. And then cos, and then the angle that's opposite the side we want to know, 25. Nice. Right, so we just need to put that into the calculator. $65.367. Okay, meters. We're going to round it to 3 significant figures. There's a 6, we round that up to a 4, so it's 65.4. Does that make sense? Yes, let's look at the mark scheme. 60 times by 4 or the unrounded answer. You get 2 marks. Okay. 1 mark for the content underneath the square root, 1 mark for the square root, and then 1 mark for the correct rounded or unrounded answer. Next we could calculate RS. RS is this distance here. Okay. Which form part of this triangle. Okay. Now, can I use the cos rule? No, because when there's angle 55, I don't have the 2 sides next to it. And this angle here, I don't have the 2, can't use the cos rule. Okay, we're not working with 3 sides. So it must be the sin rule. With the sin rule, we need an angle and the opposite side. We don't have the angle opposite the 45. Now we want to work out what's the problem? We've got a problem. We got another side here. Do we know what this angle is? Yes, we do. Angles in a triangle is 180. So we should subtract from 55 and 45 from 180. We have that angle. Write it down though, right? So 180 minus 55 and 45. Well, that's 100, isn't it? So 180 minus 100 is 80. So now we know this angle here is 80. Now we got the angle and the opposite side, so we can use the other angle we have and the opposite side to work it out. Okay, so we know we're going to use the sin rule. Okay, the sin rule is in the formula sheet. Okay. They only give one version of the sin rule. Okay. This one is best for working out the side of the triangle. If you ever have to work out the angle, of course, you can flip it around. Okay. And then that one's better for working out an angle. So they don't give you 2 versions, but just know that you can just flip around for the other version. So we can do that. Well, we want to work out a side, so we're going to use this. And of course, we don't need the whole thing. We just need A sin A over B sin B. Okay. So it's A sin A over B sin B. What would A be in this case? Well, in this case, the side we want to know, that's A. And then the uppercase A is the angle opposite it. So we want to know what is RS. So it's RS. RS over sin 55. And then B would be, in this case now we change this now to B. And that will be our B in the formula. So 150 over sin 80. So to know what is RS, we take all of this, multiply it on the other side. So we multiply it with that. Right? So it will be 150 times sin 55 over sin 80. That's what we put into the calculator. 150 times sin 55 over sin 80. 124.768. If you're going to round it, 3 significant figures, 125. Let's look at the mark scheme. 125, all the unrounded answer. 4 marks here. Okay, 1 mark for angle 80. Oh, I want red. Okay, and even if you don't have it here, but you have it up here, I'll give you a mark there. So it's always good to write any information you have down. Okay. And then 1 mark for writing down the sin rule, another mark for rearranging it correctly, and then for the correct answer, rounded or unrounded. Good. The total area of the two triangles. Okay, area of a triangle, we know, of course, it's based on half base times perpendicular height. Okay, there it is. They give us the area of a triangle. First formula on the formula sheet. But what if you don't have the perpendicular height? Like we don't have it there. There's another formula, the very last one. Half AB sin C. Okay, which means AB sin C. So again, what we need is two sides and the included angle, the angle that goes in between that. Not this that one or that angle, the angle between the two sides. So going back to our question, right, for the first triangle, let's just rub this out, which is triangle PQR, that's what we have. Okay, we got this angle and the two sides. So area of triangle PQR is half, remember, half AB sin C. So it will be half, AB is simply the two sides, 150 and 120, in any order, sin, the angle that's in between them, 25. So let's put that in. I just put 0.5 for a half. $3,803.56. Do not round this yet. Okay, let's look at the other triangle. Okay, let's change colors again. Right, so this triangle here, we got an angle here. We don't have this side. Okay, but we got this side, and we just worked out that one over there, which we got as 124.768. I'm going to be very accurate. 124.768. Okay, so here we got that. Two sides and the included angle. So this is triangle PRS. So for triangle PRS, we got half. A and B is 150 and 100, yeah. 124.768. Sin, and the angle was, of course, 45. So let's work that out. $661,682. And now we can add them together. Okay, so to this one I'm going to add 380.56. Okay, let's just do this right. $1042038. And then, and only then, if you want to round to three significant figures, should be 110,400 if you round it to three significant figures. But if you're unsure about the rounding, write the full answer. Okay, see, 10,400 is correct, but anything, okay, not from wrong working. Working out should be correct. Okay, so you get 1 mark for doing this correct, 1 mark for that step correct, And then 1 mark for the unrounded or rounded correct answers. On to question 18. We need to complete the square. Okay, you need to remember the steps for this. Alright, completing the square, we make brackets. Put the x. Then you take the b value and you divide it by 2. It gives you 4. Now you put the square there. Well, be careful, because if we do x plus 4 squared, which means x plus 4 times x plus 4, we'll do x times x is x squared. Good, that's what we want. X times 4 is 4x. 4 times x is 4x, which together will give us 8x. Good, that's what we want. But then we'll do 4 times 4 is 16. There is no 16 there. We don't want the 16. So we're gonna, if we've done this with that equation, we're gonna have to subtract 16. Okay, to get rid of this 16 that was never there. It's not in the equation. That still makes it true. But there is a minus 9 hanging around. So don't lose the minus 9. That means what I've just done now is still equal to x squared plus 8x minus 8. Okay, because we've subtracted the 16 and the minus 9 is still there. So that means x squared plus 8x. 16 minus 16 is good, but the minus 9 is there. See, this is still equal. Okay, and then the last step, of course, is just to minus 16 minus 9 is minus 25. And that's it. That's, we have completed the square. Because what we're writing down here is still equal to x squared plus 8x minus 9. Okay. Okay, so you get 1 mark for this, 1 mark for that. Done. Now we solve it. You see now what's changed from the previous equation? They have now added a 0. Just use the right color. So you got this added 0. So all we need to do is we need to write the x plus 4 squared minus 25 equals to 0. Okay, and then solve it. So first we will add 25 to both sides, which will give us x plus 4 squared equals 25. You move it to the other side. Then get rid of this square, which means we square root. Okay, but be careful now. You see we've got two answers. Yeah. 5 times 5 is 25. So that means the square root of 25 is 5. Okay, but minus 5 times minus 5 is also 25. So we can say the square root of 25 is could be minus 5 as well. So that's why we get two answers here now. We'll say x plus 4 square root of 25 is 5. But x plus 4 could also be equal to minus 5. Yes, can be. So the last step here is we subtract 4 from both sides. We get x is 1. Or we get minus 5 minus 4, which gives us minus 9. So those are the two answers, 1 and minus 9. Okay. Minus 9. Okay. Follow through. So if you made mistakes before, you do the right steps. So you seem to get a method mark for getting up to this point here. Okay, let me highlight it. This point here. Getting x plus 4 equals either 5 or minus 5. And then a mark for both 1 and minus 9. Okay, you need to do a lot of work here to pick up those two marks. Question 19, you need to recognize this is a quadratic equation, and that looks very familiar, doesn't it? Well, it's the quadratic looks got something to do with the quadratic formula. Yeah? Where they clearly tell you for the equation ax squared plus bx equals 0. That is the formula. So let's go back to the question and write down the formula. Okay, that's what you're doing. It's a weird question. It's not a question you would have encountered before, but if you just recognize what is going on here, then you can say, okay, what do I know? I know this has got something to do with this. It must have. what's it, 4ac over 2a. And then you say, hey, okay, look. I know this is a 1, so that 2a, that would give us, if I make, remember now, this is a is 1. If I put the 1 here, 2 times 1, it gives me that 2, good. The b, well, there's the b, you see, the minus is there, so the b is what goes there, is a 7. There's a 7 there and there, that's it, easy as that. The b is 7, okay, so already I got one mark here, just by being sharp. Now, under the root, we got a 61. Yeah? And that means all of this under the root, b squared minus 4ac, that should be equal to 61. But I do have some information already. Just figure out the b is 7. The a is 1 because he's the 2, stated 2, so multiply it by 1. And the c is the thing I don't know. So 7 squared is 49, minus 4 times 1 is minus 4, c. How shall we do this then? I think most people will do the following. They'll subtract 49 from both sides, will they not? So they give us minus 4c equals, what is that, 22, 61 minus 49. No, it's 12, of course. It's 12. Okay, and then we need to divide the negative 4. So 12 divided by 4 is 3. And not through this, so that's minus 3. Let's check. Yes. Okay. So you get 1 mark for recognizing b is 7. 1 mark for putting that equal to 61. And then getting the correct answer. Okay, a little bit of legwork here, a little bit of smartness, but in the end it's not that hard. You can do it. You can figure it out. Start with what you know and then see what you can figure out from there. Even though it's a strange question you've never encountered before. Or maybe you have because you've been watching my videos. All of them. And subscribing. Alright, question 20. Got a box. So you know, 3D. And again, it's triangles. Triangles. There's a box, but there's lots of triangles in it. So you know you're going to do trigonometry. Okay, the other shows a cuboid, and they show a 6, 6, and 8. Remember, if the height is 6, it's 6 all around. Okay, so we have a lot of, and we know that's all 6. And if this length is 6, we know that is 6. Okay, and this is 8, we know that is 8. Just get this clear first of all. Okay. The angle HAF, let's look. The angle HAF is this angle here. Okay. So that one going there. We need to be able to think in 3 dimensions. Okay. Now, what do we have? Start with what we do have, right? That forms part of this triangle, okay? So I'm going to highlight in blue. You see that? It's like you're slicing off the corner of a cuboid. Yeah? So that will be the triangle. I'll draw it over here. HAF. And we need to find out this angle. We don't have any of the sides of that triangle. Okay, so we're going to figure out some other stuff here. Okay. If we look at this triangle here, yeah, you see that one there, I'm doing it in green. What do we know about that triangle? Well, we know that there's a 90-degree angle. Okay, so let me draw that one down here. Let's draw it over here. Okay, let's draw it here. So that is the triangle HAF. which got the same as HA there, E. E will be a 90-degree angle, and we know this is 6 and 6. So beautiful. So you know what's going on here. We've got a right angle triangle. We can use SOHCAHTOA or Pythagoras, but we're not using any angles at the moment because we got two sides. We can work out the third side there. Then I'll have the length of this side here. So it's Pythagoras. Okay, so that side length there, HA or AH squared would be equal to EH squared plus AE squared. Okay, so it means AH is the square root, as we move that square across. EH is 6 and AE is 6. Right, so we can put that in the calculator if we want. And my calculator gives the answer as a third. Okay. 8.485281374 is a lot to write down, so you're inclined to probably round it, but if you round it too much, your answer is not really accurate enough. So it's better to write it like this, in third form. It's a lot more accurate. If your calculator doesn't give it to you in third form, you can still write in third form. You can, 6 squared is 36 plus 3 is square root 72. Which then, if you know how to do thirds, you can change it, but we're not doing that now. But you can write square root 72. It's a lot more accurate and easier than writing that whole decimal answer. Okay, so we now know that this is 6 square root 2, which by the way is 6 square root 2 here, which is 6 square root 2. So we got one side of our triangle. Right, now we can do the same. Okay, let's go on to here. We have this triangle here, the one on the front face. See that? That is the triangle. I'm going to put it down here like this, going from E to F to A. And in that triangle, we know we got a right angle here because it's on the front face there. Yeah, oh my goodness. There. We got EA or AE, which is 6, and EF, which is 8. And we can work out AF, which by the way is the same AF and the triangle we want at the beginning. So we do the same thing we just done. Okay, this is great news. We are going to do, let's do it over here. So AF squared equals AE squared plus EF squared, which means AF, get that square root gone to the other side, so the square root AE is 6 squared plus 8 squared. Let's see what that pops up for us. 10, of course, because 36 plus 64 is 100. And 9, so we got 10. So we know this is 10, which is 10 on the triangle we just got. Okay, so this is 10 here. Okay, what we got left now is HF. Can we get that? Well, yes, because in this triangle up here, so what color do we want this time? Pink. This triangle up here, I'm not going to go through it all again, but it's got sides 6 and 8. It's a right angle triangle on the top face, so it's going to be the same as this triangle here, which means HF is also 10. That's also 10 because it's attached to a triangle that's 6, a right angle triangle that's 6 by 8. So now we have 3 sides of a triangle want the angle, okay? So as we know before, if it's a right angle triangle we're working with, we use Pythagoras. or SOHCAHTOA. But now over here we got triangle HFH, which is not a right angle triangle, so we know we're going to use the sin rule, or we're going to use the cos rule. With the sin rule, you always need an angle on the opposite side to start off with. If you don't have an angle on the opposite side, you can't use the sin rule. Okay, so we don't have an angle, we don't have any angles, can't use the sin rule. Cos rule is two things, right? Either you have two sides and the included angle, then we can work out the opposite side. We don't have any angles, but we can also use the cos rule when we have three sides and we want to know an angle. Okay, so where's the cos rule? It's up here. Okay, the thing is, with the cos rule, there's another version which they don't give us. Okay, so we either rearrange, we can just use the cos rule as it is there and then rearrange everything. Okay, we can put it in there and calculate the answer. We're just going to have to move a lot of things around. Or if you want to memorize the other version of the cos rule, it's not a bad idea. Which the commonly used one is cos A is b squared plus c squared. You see, just take that bit there and then you subtract the a square and then you put it over that bit here without the minus. Okay. Make that look nice. Do you know why it's that? Because I can go through it. If you don't want to hear this part, just skip it over. Okay. I'm going to go through quickly. So, if you have a squared equals b squared plus c squared minus 2bc cos a, and we subtract the b squared and the c squared from the other side, you'll have a squared minus b squared minus c squared equals minus 2bc cos a. Then we just need to, because this is being multiplied to the cos a, we need to divide it on the other side. So we divide everything by negative 2bc. The negative stays negative. It's the times that becomes a divide. And that is a perfectly fine version to use it. The only thing they did here is they divided the minus into everything. They said a plus and a minus will give you a minus, and then a minus and a minus will give you a plus, and a minus and minus will give you a plus. So now we're rid of the minus underneath there. And then they just put the a squared at the back. So they put b squared and c squared is positive, but the a squared is negative. Put it at the back. That's where they get the other version of the cos rule. This version, of course, is better if you want to work out angles. But you can use that version. It's perfectly fine. But I'm going to use that one. Okay. So, memorize it. Don't memorize it. Try to remember how to rearrange it. Don't try to remember how to rearrange it. Just use the original cos rule, whatever you prefer. Just remember when to use it. If you've got three sides, you want to work out an angle, use the cos rule. You know where to find it. It's going to be on your paper. So let's do that. It's cos A equals b squared plus c squared minus a squared over. No. See, don't confuse it. 2bc. So, the angle we want to know is HAF. Huff. So A is HAF. Of course, that cos, we're going to have to get rid of it. Let's go to the other side. That will become the opposite of cos, the inverse. Okay. Then we have B, which I said mine was 10. Don't forget the square. Then my C was 6 square root 2. So 6 square root 2. Don't forget square minus a. Mine was 10, remember. Okay. You can swap this 10 and that 6 square root 2 around. But you have to have a minus 10 squared at the end there. And then at the bottom, you need to have this correct as well. Okay, don't use the wrong numbers. That's how we get it wrong. So, HAF equals, let's put that into the calculator. And I get 64.895. Etc. If you're going to round it, angles is always to one decimal place, which in this case is the same as 3 significant figures. But be careful with that. Okay, so 64.895 or 64.9. Yes, the rounded or unrounded answer. That's correct. Oh, something weird's going on. Okay, whew, look at this. Okay, let's look at the marks here. You can check where you get your marks. You get 1 mark for 6 squared plus 6 squared, and 1 mark for 6 squared plus 8 squared. Okay, then if you use the cos rule, the basic part, the middle part here, correctly, and then for doing calculations correct, and then for the unrounded or correctly rounded answer, you get your 6 marks. I hope that makes sense, yeah? Interesting question, this one. Question 21. The main thing to remember about graphs is that on the x-axis, the y-coordinate is always 0, and on the y-axis, the x value is always 0. So, if we want to know, and that's what we need to do here, we need to make a sketch of where these graphs crosses the x and the y-axis, we just do that. Okay, so for question 1, y equals x minus 1 squared. If we make the x 0, we'll get y equals 0 minus 1 squared, which is minus 1 squared. Remember, minus 1 times minus 1 is 1. Because a negative and a negative is a positive. So we know that graph will cross the y-axis, the y-axis at 1. Now that could be anywhere. Okay? As long as you show, well, this is 1. Okay? And then we make the y 0, which will give us 0 equals x minus 1 squared. There's 2 ways to interpret how we're going to do this. One way is just to say, right, fine, we need to get rid of the square. So that we need to do the square root of 0, which is 0. And then we move the 1 across. So that means x equals 1. The other way is to say x minus 1 equals 0. It's the same thing. So we know it crosses the x-axis at 1, or does it cross it? Now that's the question, because remember, this is a quadratic graph. If we were to expand that brackets, not that we have to do it, we'll get x squared minus 2x plus 1. Again, that is where it crosses the y-axis. Okay, but it's a quadratic, and a quadratic graph is always a parabola. Now, a parabola often crosses the x-axis at 2 points, unless it doesn't cross it at all, or it only touches it. So that's what's going to have to happen here. It's going to be a graph that comes and then touches and then goes up. But it has to be a parabola because it's quadratic. There's a square in it. Okay. Now let's do the other one. And we're going to do the same. But this, of course, is a straight line because it's in the form y equals mx plus c. So we know it's going to be a straight line. So again, y equals a half x plus 1. Let's make the x 0. That means y equals a half times 0 plus 1, which gives us y equals 1. So again, this straight line is going across the y-axis at 1. Then we make the y 0, which gives us 0 equals a half x plus 1. Subtract 1 from both sides. And now remember, half x is the same as x divided by 2. If you half something, divided by 2 is the same thing. So we multiply the 2 on the other side, or we divide it by a half. Either way, we get minus 2. X is minus 2. So we know it goes through minus 2. So just roughly, minus 2. You just guess what it is. Minus 2 will be there. Okay, so it will be a straight line. You draw with your ruler, going like this, crossing the graph twice. Let's check. Okay, the mark scheme, it doesn't actually see, like they want you to actually say where it crosses. So if you just got the shape right and the right position, okay, 1 mark. They say if it's upside down, then you get 1 mark. Okay, because anyway, yeah. Alright, same here. If you had a line that goes the wrong way like that, 1 mark. Okay. But for 2 marks, okay, so this one is 2 marks. It needs to cross there at the same place as the other one. There's of course other ways to do this. You can use the gradient, which is a half, 1 over 2, to get these points. You can create a table, like a table, and then put the stuff in the table. Yeah, there's other ways to do this. Okay. In part B, do note carefully that we still have the same equations. We got x minus 1 squared and half x plus 1. Okay. So what they're telling us now, they are intersecting, crossing at A and B. Okay. So we can only assume this is point A and that's point B. Doesn't matter if it's the other way around because the length of the line doesn't change. Okay, so from one point to the other. Okay, so we know now from everything I've done so far that at point A the coordinates are probably 1, 1. No, 0, 1. Because the y is 1 but it's on the x-axis, of course, because we made x 0 and we got 1 for both. How do we find the other point where they cross? Well, where they cross, they are equal to each other. Okay, meaning at this point here, there's a coordinate with an x and a y value. And that x and y value is the same for both graphs because it's the same point on both graphs. That means their y will equal their y. It means that all of this will equal all of that. You use that. So that means x minus 1 squared equals a half x plus 1. They're equal to each other. Okay. So what can we do here to solve this? Square rooting the right is not going to help me at all. So what we can do is we can expand these brackets. Okay, see this is 7 marks, so you know there's a lot gonna happen here. Expand the brackets. X times x is x squared. X times minus 1 is minus 1x. Minus 1 times x is minus 1x. And minus 1 times minus 1 is plus 1. Be careful with the signs. Let's simplify that. So that's minus 2x plus 1, because minus 1 is minus 2. Right. I'm going to chuck everything to the left. Okay, so that will give us x squared minus 2x minus the half x plus that 1, but we move the other 1 to the side again, is minus 1. Okay, you see that? I've taken the half x on the right, subtracted on the left. Plus 1 on the right, subtracted on the left, or subtracted from both sides. Okay, what does that give us? It gives us x squared minus 2 minus a half, of course, is minus 2.5 x, and plus 1 minus 0. Okay, we need to solve this now. To find out what is x, that minus is ugly. How are we going to do that? There are different ways of doing this, different ways. Okay, one way is to factorize. Let's do that. Factorize out an x. Take an x from the first term and the second term, write it in front. So we're left with taking an x away from here, so you still need to be an x, because x times x is x squared. The minus, and I'm going to swap to decimals just because it's a bit more comfortable for me. X times minus 2.5 is minus 2.5x. That means x equals 0, but we already knew this because that's what we got there. We knew that at one point x is 0. Okay, and if we make x 0 in any of those equations, we get y is 1. That's why we know this is a point where they cross. But on the other side, we have x minus 2.5 equals 0. That means x, so add 2.5 to both sides, is 2.5. So brilliant. What we know now here is, if we go down, this would be 2.5, or we put it there. Okay, 2.5. This is a comma, by the way. Okay, which make everything make sense still. All right, so we know that for b, the x coordinate is 2.5. We just need to find the y. This is the x, that's the y. Where can we find the y? Well, there's a y over there, and there's a y over there. So we can use any of them. Let's use the one without a square. Maybe that's easier. So, to find y, we're going to do a half times 2.5 plus 1, okay? Because I've used this equation now. So what's a half of 2.5? 1.25 plus 1 gives us 2.25. Okay, so 2.5 and 2.25. But ugly. By the way, we should get the same answer if we do it with this one. Let me do it with the calculator. So bracket, and we said x is 2.5 minus 1, just check it quickly, squared, it should also give us 2.25, which is, yes, got the same thing. So it doesn't matter which equation we use, and it's a good way to check if you're on the right track as well. So the same up here now. Okay, let me just give myself more space. Okay, we know that this will be 2.25. So the point there is 2.5 and 2.25. Okay. Right, we're doing good. Well done. Now, got the two coordinates. Let me write them down. Okay, remember, it was A was the point 0, 1, and B is the point 2.5, 2.25. If we go here now, we need to find the length of this line, AB. We can make a triangle out of this, because then we got a right angle triangle. And who's that guy? Pythagoras. Okay, and now we know the distance of the base here is 2.5, And the height of the triangle goes from 1 to 2.25. That's 1.25. You see where we're going? Now we just need to do Pythagoras. But there's a formula for this as well. Okay. So if you want to find the length of AB, if you put these two lines, which, what does it mean again? It's a positive absolute value. That's the length. It's always positive. Would be Pythagoras. This is the formula. Probably getting a textbook. And then we got x1 minus x2, or x2 minus x1, I can't remember. Okay, squared plus y1 minus y2. Or should we do it the other way around? It doesn't matter actually, because if you square a number, it always becomes positive. Okay. Maybe that's it, x2, okay. It's just like if we call this x1 and that's x2, and we call this y1 and that's y2, then you'll do 2.5 minus 0 equals 2.5. So that's exactly what we just saw here. That is 2.5. We saw it by applying logic, but if you put in the formula, gives you that distance. And then y2 is 2.25 minus 1. And that will give you the 1.25, which we by logic figured it out there. If you put it the wrong way around, you're just going to get negative 2.5 and negative 1.25. But when you square those negative numbers, they become positive. So it doesn't matter if you have your points the other way around. If you got your A over there, your B over there, or you got your formula, right? You just subtract the one x value from the other one. Okay. When you're doing other stuff like the midpoint, you need to have it in the right order, okay? But in this case, it doesn't really matter. So what we want then is 2.5 squared plus 1.25 squared. And we get 2.795. Etc. Gonna round it to three significant figures. 2.80, of course. Let's check the answers. 2.8, you don't have to have that little zero. It just shows you've rounded it to three significant figures. But if you put 2.8 in this case, you get your marks, or the unrounded answer. Okay. A lot of marks here. Okay, it's difficult to go through all of every single mark because it all depends, but you got a mark for finding these points. Alright. You get a mark for setting the two equations equal to each other, and then for rearranging it correctly, you get a mark. How much? That's 4. You get a mark for having 2.5 and 1.25. And you get a mark for using Pythagoras. Where are we at now? That's 6. And then of course a mark for the correct answer. It's a short summary of how the marks is applied, but of course in reality it will be a bit more complicated than that when they mark your paper. But you get an idea of what's going on. And finally, question 22. Simplify. So they algebraic fractions here, they really gone out of their way to try and make something beautiful for us. Okay, where are we going to start? The top or the bottom? Well, you decide what is easier for you. Factorize the top, which of course would be a quadratic equation with a 2x and an x, or the bottom, which we can factorize separately. So maybe this will be easier. If I factorize out this a, I'll be left with x plus 3. And here I'm going to factorize out the b, but also the negative. And I'll show you why. If you factorize out the b, 2b, just do it over here. So you got minus 2bx minus 6b, which we can write as minus 2 times b times x. And 6 we can write as minus 2 times 3 times b. So what I'm doing is I'm factorizing out the minus 2b. So we're left there with an x, and here the minus 2 and the b, that's gone in front already. We're left with a 3, which is positive, because if I do minus 2b times x, I get minus 2bx. And if I do minus 2 times 2b times 3, a minus and a plus is a minus. 2 times 3 is 6, and then there's a b. Okay, so it's minus 2bx plus 3. Because we want those two brackets to be the same, because then we can factorize them out. So imagine we had ax minus 2bx, yeah? Imagine we had that. And we factorize out the x. We'll put it in front, and we'll left with a minus 2b. Makes sense? Thing is, now we don't just have an x, we've got an x plus 3. So we factorize out the x plus 3. And we're left with a minus 2b. That's the two terms that is left. So what do we learn from this? Okay, if there's a minus, you can factorize it out. You factorize it out. Remember, a minus and a plus is a minus. And you need to practice this type of question. Okay, the reason I liked doing the bottom one first is because when they give you a question like this, and you know it's the last question and it's 5 marks, there's always going to be a bracket at the bottom and the top that is the same. So when we factorize a quadratic where the first coefficient is not 1, I mean there's a 2 in front of the x squared, or a 3 or a 5, okay, one of the brackets is just x, and it's going to be the same as one of the brackets below, which could only be. Alright, so now I know the last term here, the minus 15, is gotten by multiplying the last two terms in the bracket. So this is plus 3, this must be minus 5, because minus 5 times 3 is minus 15. Okay, we can check if this is correct. So we get 2x minus 5, x plus 3. 2x times x is 2x squared. 2x times 3 is 6x. Minus 5 times x is minus 5x. Now, we got the 2x squared, great. 6x minus 5x will give us 1x. Great, that's what we want. And then 5 times minus 5 times 3 will give us minus 15. That's the last term. We know it's all good. All good. Okay. Of course, there is other ways to factorize quadratics like this one. There are many methods and many videos online, and I can pick one and show you, but I think it's good if you just type it in. Factorizing quadratics where the coefficient is not 0. Something like that. You'll get some explanations of that. Anyway, what we got now? We got two brackets the same. We divide them. They cancel each other out. We're left with 2x minus 5 over a minus 2b. And that, ladies and gentlemen, I'm pretty sure is the right answer, but let's check it anyway. 2x minus a over minus 2b. Lots of marks to be picked up over here. Okay, let me see what I can. Okay, I forgot to put it in here. Okay, so 2 marks for this. If you've got it wrong, let's say you swapped the minus 5 and the 3 around, which means in the wrong place, you can get 1 mark. Okay. 2 marks for this below the line. Well, actually, one mark for this and then 1 mark for that. Okay. There is another way to factorize this, by the way. But I'm not going to go through now. And then of course your fifth mark there, and then you have snow. You finish the last question and you just aced the paper because you can do it. Okay, this has been fun. See you again soon. Bye bye.